to the days when you guys first learned how to work with fractions and you had to solve equations that had fractions in them, there was a shortcut to get rid of them. If I wanted to get rid of a fraction within a problem, for example in this one, I have x over 3 plus x over 4 is 7 over 4. And I want to get rid of all of those fractions. Since there's this crazy symbol in there called an equal sign, I can multiply both sides of an equation and it will still hold true. What would I want to multiply both sides by to get rid of the fraction? 12. And what is 12 in regards to the 3 and the 4? The least common multiple. Same idea that you did yesterday when you had to combine like terms by working with the common denominators. What we're going to do today is we're going to use that common denominator to get rid of all of our fractions. I'm going to show you a couple examples numerically prior to introducing more of the variables to getting into more of the factoring style. It all is based off the exact same premise. The idea of what we're about to do here doesn't change for any of this. Now, you guys all agree that I can take this equation and multiply everything by 12.
Yeah.
All right? So here's what I'm going to do. These first 3 or 4 of the problems I'm going to work with today, I'm going to show this distribution step. Send the 12 to everything. You get 12x over 3. 12x over 4 is 12x, or excuse me, 12 times 7 over 4. Some of you guys might pick up on what's going on here real fast, and that's fine. But I'm going to kind of show you what you're doing here. What's 12 over 3?
4.
See what I did there? I just simplified each individual term. What's 4x and 3x? What's x?
3.
Let's have problems like that.
Okay.
You didn't say no.
I didn't say no, you're right. Same idea. Same idea here. If I'm looking at x over 3 minus x plus 2 over 5 is 2. I'm going to still go through the same process. I want to get rid of the fractions. What do I want to multiply everything by in this case? 15. Good. So if I multiply everything by 15, again, I'm going to show this secondary step. I have 15x over 3 minus 15 times the quantity x plus 2 over 5 is 15 times 2. Again, all I did was just distribute to all 3 terms. What's 15 over 3? What's 15 over 5? It's gone. What's 15 over 5 then? 3. Excuse me there, I know it's coming back. And then lastly, what's 15 times 2?
30.
Notice, all I have done was just eliminate my fractions. What I'm doing here is I'm keeping both sides of the equation happy by multiplying both sides by the same value. It doesn't change the equation, it just makes it easier to work with. Distribute out. And you get 2x is 36. X is 18.
That's all right.
You know why you said 12? Because you wrote down plus 6 instead of minus 6. Remember, you're distributing out a negative there. Okay? notice we're really not changing anything up here from working with numbers that you've done in the past. You're just getting rid of the fractions to make your lives easier. Yes, sir?
That was 15x plus, like, was that x plus 2 not in parentheses? Would you, oh, what's the original problem?
It was x plus 2 in the numerator.
You can't do 15x plus 30?
You can. But then you won't be able to, but then you still can simplify 15x over 5 and 30 over 5 to get, what do we have here? 3x plus minus 6. You'd still get the same value. What I'm doing here is by writing it out
Oh,
in
I
that.
think I mixed the sign.
Okay.
I think I put x over 3 plus.
By rewriting everything within the grouping, you don't have to worry about that extra distribution thing. But yeah, just watch, if you watch your sign, oh, if you write it down correctly too, that's
Yeah,
okay.
because I got 5x plus 3x plus 6 plus 30.
That's why.
And I got x plus 5 now, so like, I don't know, I thought it was because I didn't write it like you would.
Again, 3x plus x over 3 is 5. What are you going to multiply everything by? 3. If I multiply everything in here by 3, now I'm going to skip this step here and just write it out. What's 3 times 3?
9.
What's 3x over 3? And what's 3 times 5? Is everybody okay without me showing the actual distribution step?
Yeah.
All right. What's 9 plus 1? It's 8. And you get 3 halves. Again, what we're doing here is we're getting rid of our denominators. We're getting rid of the fractions. So the process by using this numerically isn't going to change when we go into algebraic terms. You're still going to identify a common denominator and multiply it through. For example, like this. And now we have variables on the bottom, in the denominators here. So 4 over x plus 5 over 2 is 11 over x. And what I want to do here is I want to multiply everything by a common denominator. 2x. Does everybody agree on that?
Yeah, 2x.
Good. So if I multiply, and I'm going to do this the long way with this one. If I multiply everything. Oh, real fast, just in case you didn't recognize this. That's a negative. I put the negative symbol next to the 11. Sometimes it's easier for students to see that. It's a negative 11 divided by x. I don't know. The book sometimes puts the negative in front of the fraction bar. If you remember to put the negative on the numerator, you'll be less likely to mess up anything. All right, again, we identified the common denominator to be 2x. So by multiply each term by 2x, we get 2x times 4 over x plus 2x times 5 over 2 is 2x times negative 11 over x. What you're able to do now is that you have 3 individual monomials. Each one of those, guys, come on. Each one of those can be simplified. What drops out in the first group? The x's go away. What's 2 times 4? 8. What drops out now? What's 5 times x? And what drops out? What's 2 times negative 11? Fractions went away. Okay? They have disappeared. Winds up as a very simplistic 2-step equation. 5x, negative 30, x is negative 6. Do you see why we had to work a lot on those common denominators yesterday? And it becomes more useful now. it comes in, we start getting in larger and larger terms. Okay? Suggestion. When you have a setup like this with a singular number there, when you're writing it out, put it over 1. That way you know where the 7 is supposed to be. A lot of times people forget. So we have 5x over x minus 2 is 7 plus 10 over x minus 2. What's going to be the common denominator between an x minus 2, a 1, and an x minus 2? X minus 2. Again, I'm going to multiply everything by the common denominator. Distribute through. And if you don't want to show that step that I just did, that's fine. What's going to drop out? X minus 2 drops here, so I have 5x equals 7x minus 14 plus 10. Wait, what? Correct. Take a look at what happened here. We said that x is equal to 2. Can x be 2?
Yeah.
If x is 2, what happens? You can't. Can you divide by 0? You have to sometimes go back and double check your work. This is a no solution.
Wait a minute. If it makes
Oh, you can't just throw that
Yeah,
in.
you can. Yes, you can.
You can't do that.
Yes, you can.
I got the right answer.
What'll happen from time to time? It's very easy to recognize what happens. If you're taking your time, you remember what the original problem was. Take a brief second, look at the value you got to see if it's what they call an extraneous solution. We've done that before. We've worked with those before. What happens is it'll just say check for an extraneous solution, which means if your variables are in the denominator, just double check to make sure it doesn't make it a 0. Right? That's all it is.
Does that
What's
have
that?
to make both of them a 0 or just one?
If it makes one of them, bless you, if it makes one of them a 0, it's going to be a no solution problem. Okay? Because if this was like an x minus 2, and the other one is an x plus 2, you would still have a 0 at 2. It won't work. All right? The moment you divide by 0, bad things happen. The world explodes. Cats, dogs living together, complete pandemonium. That whole thing. All right. I know what that movie's from. That's from Ghostbusters. All right. Let's take it a step further. You'll notice each one of these individual problems starts to become a little more complex. There's a little bit extra to all of them. In the other problems that we've looked at so far, we haven't had to do any factoring of the denominators to begin with. In this one, I do. What do I have to factor here? Yes, sir.
Multiply that first from like the left side of the sign by x minus 1. Look the top is by x minus 1 over x.
Right, so let me ask you guys this. The x squared minus 1, what does that factor to be?
X plus 1, x minus 1.
So what I'm going to do here, just underneath this, is just kind of write x minus 1, x plus 1. I know this is over 1. What's going to be the common denominator here?
That's a good question.
X plus 1.
It's x minus 1 and x plus 1.
So
Okay.
plus and minus.
Because, yes, these guys both have the x plus 1 in common, but what else is there? There's an x minus 1 and a times 1. So my common denominator for all of these guys is going to be x minus 1, x plus 1. Now think about the process by which we've been working so far after we distribute, something would drop out. Like Paul just said a second ago, this first term already has an x plus 1 in it, which means if I multiplied it by an x plus 1, x minus 1, the x plus 1s will drop out. What am I left with? X minus 1. So my first numerator will be 4x plus 1 times x minus 1 equals. Does the 12 need to be multiplied by anything? It does not. Good, because it has both of them already. And what does the 3 need? It needs both. And I like what you're saying here. Could I, instead of writing it 3 times x minus 1, x plus 1, can I just write it as, can I do that? The reason I'm going to do that is just a little bit shorter. All right? Not always going to be that easy to work out. Sometimes you will have like an x minus 1 and an x plus 6 that you have to FOIL out and then distribute to the like a 3 or something. But in this case, it just makes my life a little bit easier to solve through. So now what do you think you have to do in order to solve for x? FOIL combine like terms. Oh yeah, let's see. 4x squared minus 4x plus x minus 1 is 3x squared minus 3 plus 12. Now I have, yeah. Because we did. If you go back to, you look at what we skipped on here. We skipped the part of writing x minus 1, x plus 1, 4x plus 1 over x plus 1. Because why did we skip that? Because that's going to drop out, and it allows us to go right here. So in essence, once we write out what we're multiplying everything by, as you go piece by piece, you look and see, all right, this one already has the x plus 1, I don't have to write it. This one has both of them, I didn't need to write anything. This one needed both of them, I had to write for both of them. Does that make sense?
Yes.
Good. Bring the 3x squared and the 9 over to the left. Nope, that's plus 9, sorry. So we have x squared minus 3x minus 10 is 0. So there's lots of foiling and factoring and foiling. What times what's negative 10? You add together to get negative 3. Negative 5 and 2, good. What are your zeros?
5 and negative.
Are they both okay?
I hope so.
Did they make a 0 out of the denominator?
No.
Should be okay. Again, once you identify your common denominator, you multiply all parts by that, the fractions go away, and it's a matter of combining like terms and solving for x, which you've done many, many, many times. Right? Now what do you do?
Do we have a lot of notes left?
I got more paper.
I know, but I don't like going on 2 pages for notes.
No.
Go to the back side.
I don't like that.
What do you gotta do now? What's the first rule of factoring, guys? What's the GCF? What's that? Yeah, what's my GCF of the denominator on the left?
X minus.
Well, what's the GCF? X. I know. So if I factor out just the x, fraction on the left has an x times the x minus 1. Fraction on the right is just an x minus 1. What's going to be the common denominator?
X minus 1.
And the x. Good. So it has to be multiplied out by x and an x minus 1. Does the first fraction have both of them?
Yeah.
So what does that simplify to be?
2.
The second one needs the
That's
Great.
sweet. That's sweet jelly.
Fantastic.
No.
Smack. Oh wait.
What's another way you can solve anything that is fraction equals fraction? Cross multiply. Anytime you see fraction equals fraction, you can go ahead and cross multiply. It will work the same way. If you did it that way, you get 2 times x minus 1 is x squared minus x.
Oh.
Move the stuff over, you get x squared minus 3x plus 2, which you'd have to factor. Now, you get zeros of 2 and 1. 1 won't work. Your only answer would be 2. It works the exact same way. It works the exact same way. One way is sometimes easier than the other. It just kind of depends upon the problem. There's no right or wrong way of setting those up. You do have to be careful, though, with extraneous solutions when you cross multiply. That will be one thing that will happen. Now, when you do the factoring form of it, it eliminates the need of an extraneous solution 9 times out of 10. This one. Gentlemen, it's enough. You guys talk way too much. Okay? I give the opportunity to sit where you guys like to. I get it. But I have to keep telling you guys these things that we're all moving. It's really getting old. And I've had to tell you guys this before. Try this one out. You can go 2 different ways. You can go ahead and get your GCFs, or you can cross multiply. It's totally dependent upon how you see it and how you want to go through it.
What'd you do?
Did you get -5?
Yes.
Did you guys, did anybody cross multiply that one?
I did.
I tried.
Same thing, right?
Well,
You should.
if you cross multiplied,
Hold on, guys.
would you get x squared plus 2x minus 15 if you brought it down all the way?
If you cross multiply, you get 5x squared minus 45 is 2x squared minus 6x. 3x squared plus 6x minus 45 is 0. Take out the 3, you get x squared plus 2x minus 15. X plus 5, x minus 3. Negative 5 and 3, and that one won't work. Cross multiplying sometimes is not a shortcut. Because you have a lot of signs and stuff to worry about. It'll work. It works. It's actually easier to do the cross multiplying if you don't have to worry about squared terms. If you have to worry about squared terms, I would kind of steer clear of cross multiplying, to be honest with you. So, again, the whole idea here is, ladies and gentlemen, make sure you get a common denominator. Multiply everything by the common denominator, and your denominator should all go away. And you should be happy with a 2 or a 3-step equation. Okay? Questions? Let me give you a couple of these problems to try. Right here. It's on page 571.
A couple is two. Mark 20, just like do it.
How about a pair of couples?
So 4? 4? Oh, that's fine.
Okay.
I like that.
Give those 4 a shot. We come back on Monday, we'll go over this. Like I said, this shouldn't take more than 10, 15 minutes to go over. Give you guys that real brief quiz over the 3 sections. And with whatever time we have left, we'll start hammering out some of the review stuff. All right? Let me give you guys that review stuff.